Hello again. Let's finish this model. So we have our beam here. Remember, there's a pin on the left, a roller on the right. I want to put a load on here. So I'm going to pick a load. I'm going to pick a force. And I need to select where it's going to go. So it says select object. And right now you see it's not letting me select anything. That's because a few minutes ago I right-clicked up here, and you can change your selection filter. So it's going to default to a surface, but I don't want the load to go across the whole surface. I want it to go just at the middle of the beam. So I have a pin on one side, a roller on the other, and a force in the middle is what I want to have. So I'm going to put node in here, and then I'm going to go along here, and I'm going to pick a node. So I'll pick that node, and I can apply my force. And let's say, I'll say 100 newtons, specify the vector. I'm going to click on here. That's going to tell it the direction. I don't want my force to go up, so I'll click that, and you can see it's kind of like making a bigger Z going up. I don't want it to go up, so over here in the box, it says reverse direction. I'll click that. Now my load is going to go down. All right, so you can see I did it this way first. So you can see that force is just going to be at that node. What I really want is for this to be applied equally across the top. So I don't really just want the force here, so I'll go and edit this. But I want this to be applied right in the middle of the beam, and I just picked the node. So I need to know if I picked the right node. Sometimes it's obvious, but maybe I don't know where that node is. So I clicked on this node element little icon here. So now I can click the node, and it tells the number right there. And if I say OK, it's going to open up this box, and it's going to tell me that that node is located at 280, 60, and 30. So my beam is 600 long, so I would like this first dimension here to be 300. That would be right in the center of the beam. So I don't have it quite where I want to put it. I'm going to leave it there, though, as a marker, so I know where I am, and maybe click on this node right next to it and see if that one is that's 290, so they must be every 10. So I could just keep doing this, although I'm sure 604 will be the right place. Yep, it's right at 300, the x coordinate. So I'm right in the middle of the beam with that node. So that's right here across 604 and all these nodes across the beam. That's where I want to put my load. So we'll go back, say force, and let me right click. It's still set to just allow me to click on nodes. So that's fine. I want this node. I want that node. See, it's making little circles, little orange circles. All right, so it's going to apply across here. And I'm just going to pick a magnitude of 100 newtons. So this 100 newtons will be spread evenly across these nodes. So the total force will be 100, but each node will carry a part of that force, evenly divided. Specify the vector. I want it to go in the z direction, but I don't want it to go up, so I'm going to click this reverse direction and hit OK. So here we have our force. It's where I want it to be located. It's the magnitude I want. I don't want this one anymore. Before I could click it here and delete it, but I also want to show you that all of the actions, all of the things that we're doing over here are displayed in this little tree on the left. So if I click on the plus here, under loads, there's two forces. So this one is force 2, this one is force 1. If I don't want this force, I can either click on the model and get rid of it, or I can click over here in this little menu tree and say remove. Okay, so it's gone. So I have materials, elements, supports, and loads. I'm ready to run it. To run it, I click up over here, solve. Now it brings up this little menu that'll let you make some changes if you want. Just go ahead and say okay. Everything is fine to run it as default. I'm doing this through the VPN from home. It was very quick. And say okay. It's all done. It leaves these windows open, which is kind of annoying, but you just need to close them. You don't need them once the solution is done. And this says completed, and to get rid of this box, you have to click cancel. So that's how that goes. Over here, results, if I click the plus, I see this little icon, and it has colors, and so that means I have results. And I knew I had results because the pop-up box said that the simulation was done. If I right-click on this, now I have the post-processor, which lets me look at my results. I'm going to come over here on the left and click this little plus button, and it says displacement, rotation, stress, reaction force, reaction moment. There are two stresses because one is stress at the nodes and the other is stress at the elements. So I'm going to click the element stress because that's considered the more accurate stress. If you double click that, it's going to default to von Mises stress. So this is how it's deformed. Remember, I want to have the normal stress. So in this case, the normal stress direction, the stress from bending would be a normal stress, and it would be in the x direction. So I want this XX stress here. So if I click that, we can see what that is. Let me just make sure it is the, yep, that's the x direction. So it varies through the thickness, but it's not linear, so I was a little surprised by this. I actually ran it earlier. I thought that using that 20-noded element, I would get linear variation in stress, and I'm not getting that. I wonder if I do this with the the node stress. So that's a little bit, this is going to try to take the stress solution and carry it back to the nodes. So that's a little bit nicer. But I haven't bothered to calculate what the stress should be. I don't know if this is a good number or not. So I'd have to do that using the my divided by I, the bending stress equation. Lots of forms of it. So if my over I doesn't sound familiar to you, you're probably used to using a different equation for the stress. It's the same equation, just expressed a different way. Displacement, I can do magnitude. If I'm looking to compare this to the displacements in the beam chart, then I probably would like to just look at the y deflection because that's the one that's going to be in that chart. So these are units of millimeters, so very small deflection. You might look at this and say, hey, that looks like a lot more deflection than this very small deflection. That's reflected in the numbers here. And that's because deflections are magnified. So if I click on Edit Post View here, it gives me some options. Here where it says deformation, if I open this little box, it lets me choose the magnifying factor, the scale factor. So if I change this to delete that so it's 1, and I can have percent model or percent absolute. So percent model takes the largest deformation and scales off that. I'm just going to do percent absolute and say OK. And so you see if it's 1%, there's like no deflection at all. So that's really what's happening. It's not really visibly deflecting with that load on it. What else can I show you? There's different things in here. You can change the legend, so you can change the color scales here. I use this one a lot, but it's probably not too useful for you. You can get rid of the edges. So if I do that and hit apply, it should get rid of, yeah, it got rid of all the elements. So it just shows me maybe a prettier picture without all the elements, and then you can change and make it translucent. Okay, well, it's not letting me do that. Oh, yeah, it did. This translucent feature is good if you have an assembly and you're looking at several pieces put together. And the last thing I'll do, actually, let me turn the elements back on so we can see them. All right, is this button right here is identify results. So if I wanted to see the result at a particular point, you can click on it and it's going to display it up here. If I clicked a whole bunch, it's going to tell me a max, a min, and then I can click this button right here and have it send all the information there to a spreadsheet. Sorry, it opens up kind of funny. So here's the different nodes I picked. These are where those nodes were originally, and then these are the displacements. So there is that, and I can, sometimes for my work, I do this. I have a bunch of information sent to an Excel sheet. All right, so let's say I'm done looking at this. I don't really like this solution. I want to do something else. I can click up here and it says return to home. Now I'm back in that simulation file, and I could change the loads. I could change the constraints. I could go back to this FEM file here. I'll double click it here and it will open up the FEM file. Now I could say, I don't really like this. I really want to go back and change to the tetra element, which is not, oh, it won't let me do it because if I right click here, it doesn't have a selection filter. Why are you not letting me? I'm in the FEM file. I should be able to select this and change it. And it doesn't want me to be able to change it. Let's see. So if I come over here, this 3D collectors, that is where the mesh is stored. So there's the 3D mesh. I can, sorry, turned it off. I can delete it, and then that should, if it's deleted, it should let me select that body. Okay, so now I can put a different element on it and go through the process again. All right, so that's at least enough to get you started. I will stop the recording and post this, and then you can try it yourselves and contact me if you have more questions.